Good morning. The first thing I'd like you to do today is to go ahead and pass your homework to your table partner. If you haven't already done so, you should pass your green sheet as well. If you haven't done that, you're going to want to pause the video because I'm going to go through how to grade it. And then once you're ready to grade, then you'll want to start the video back up. For the homework assignment, they should have done number 2, which is worth 1 point, 18 and 20, which are each worth 1 point. Number 26, which is worth 1. 28, which is worth 1. 30, which is worth 1. Then you get down to 32. They should have selected a letter. That is worth 1. And then 34, they had to find the entire distribution and then do the histogram. So that one is worth 2. They get 1 point for doing the distribution from 0 to 6. They get 1 point for doing the histogram. Oh, actually, there's more than that. There's 4. Then they were asked if it was symmetric or skewed, so that's 1. And the least or the most likely number of outcomes, which was 3. So number 34 is actually worth 4 points. 1 for the distribution, 1 for the histogram, 1 for symmetric or skewed, and 1 for the total number of successes. So please take off accordingly. Number 44 is worth 1. Just had to find one thing. Number 46 is worth 2. Again, they should find for A, part A is worth 2. They should have done the distribution. That's worth 1 from 0 to 10. And they should have made a histogram. That's worth the 2nd point. And then for 46B, that is worth 1 point. So 46 is worth 3 total if they didn't do A or B. I'm getting 14 points there. So if you would figure out how many they completed and subtract that from 14 and record that on their paper and then on their grade sheet, you can pass that back. I'm going to go back, and once you get that pass back, I'm going to put up the answers. So you might need to pause again. So these are the answers for the first ones. So again, I'm just going to give you these answers, pause the video, and I'm going to give you the next set. So the first ones are here. And then there's the second set. So once you're done grading that, you're going to want to go back and try the warm-up. So I'm going to flip back to that. So again, pause if you need to. So you'll want to try this warm-up. Make sure that you're understanding how to do this warm-up. So pause while you do this one. So after doing this one, your work, it's asking that exactly 1 person in a class of 35 is allergic. So you should have the probability that your number of successes is 1. So you have 25, choose 1. The probability of success would be the ones that are allergic to these things. And the probability of failure would be those that are not. And so you would need to type that into your calculator and figure out what that's giving you. Should be a pretty high probability there. I do not have that on my paper, so I can't give you the answer here. Okay, you should also have a handout for today. So 6B.3 day 1. Today we're going to be talking about normal distributions. These are our objectives to be able to do these 6 things. Describe why we have a normal curve, what it tells us, explain why the total area under a normal curve is 1, estimate the percentage of a normal population falling within 1, 2, or 3 standard deviations of the mean. Use the mean and the standard deviation to fit to a normal curve. Use the mean and standard deviation to find the normal probability, and then interpret normally distributed data with respect to a word problem. So we are going to be taking that information that we did with measures of central and measures of dispersion and apply that here to the normal curve. So yesterday we talked about binomial distributions. Today we are talking about normal distributions. So a normal distribution is just another type of distribution, probability distribution. It is modeled by what we call a bell-shaped curve or normal curve, and it's always symmetric about the mean. So basically what we're doing is we are fitting these things to a bell-shaped curve. So it says a normal distribution with a mean of x bar and a standard deviation of sigma has the following properties. The total area under the curve is 1 because we're adding up to 100%. So everything possible we could have would be under this normal curve. So if you added up all the percentages, they would add up to 100% or 1. 68% lies within 1 standard deviation of the mean. So down here at the bottom, you will see x bar, which is mean. If you do x bar plus sigma, that's 1 standard deviation above. X bar minus sigma is 1 standard deviation below. So between those two numbers, and we're going to put numbers to them instead of a bunch of variables, but you do need to understand the variables because you'll have that on the homework, that is 68% of the data. So since it's symmetric, each part would be 34. So if you look over here, this diagram at the right, you're seeing that the left and the right part are mirroring each other, and those are 34% between x minus sigma and x plus sigma. So 68%. 95% lies within 2 standard deviations of the mean. So if you go out to 2 standard deviations below and above, that's where you're going to see the 95%. So if you take 95%, subtract the 68% that overlaps here in the middle, and divide it by 2, you get 13.5%, 13.5%. And then it says 99.7% lie within 3 standard deviations of the mean. So that's this entire part here. So if you subtract the 95%, again, that would already be overlapping in here, and you subtract that amount, you're going to get 2.35% on each side. So then above and below 3 standard deviations from the mean, you do have a little percentage here. You'll see 0.15% on each side, because from the middle all the way to the right has to add up to 50%, and from the middle all the way to the left has to add up to 50%. So if you add 34%, 13.5%, 2.35%, and 0.15%, you would get 50%. You do have to know those numbers. Now remember, we have a quiz tomorrow. This is not on the quiz tomorrow. This is your homework that's due tomorrow. But you do have to get these numbers memorized before we take the next quiz and the test. So if we take this and just kind of break it down, just so you can kind of see what it was saying. Again, within 1 standard deviation of the mean. So if we put the mean in the middle, we're going to take the mean plus sigma, the mean minus sigma. And again, we're going to put numbers to that. Within 1 standard deviation of the mean, you got to remember it's 68%. So each part would be 34%. Because from here to here is 68%. That's what that diagram is showing you. Within 2 standard deviations of the mean, so x bar minus 2 standard deviations, x bar plus 2 standard deviations. So we're talking here and here. So within that, that is 95% of the data. Okay, obviously you see that the curve is higher there. So when you take 95, subtract 68, and divide by 2, that's where we get to 13.5%. If you're not seeing that, I would encourage you to do that. If we subtract 3 standard deviations, or add 3 standard deviations to the mean, little small lines on each end, so that is the majority of the data. So that is 99.7%. Again, if you subtract off the 95 and divide by 2, you're going to get 2.35% for each of those. So then, again, each part, each half would be 50%. So 34, 13.5, 2.35, you subtract that from 50%, you get 0.15%. And you will see, we kind of call that the tail. There's really not a lot of data under that curve. Okay, it's very, very small. And even if I shade it in here, there's very, very little there compared to the rest of it. Okay, so that's kind of the idea there. So let's take that normal curve and let's apply it. It says a normal distribution, if I can read correctly, has the mean of x bar and the standard deviation of sigma. For a randomly selected x value from the distribution, find, and this is where you have to understand the notation. Okay, so this is my x value. So it's all compared to the mean. So every time you have a problem with normal distribution, you want to draw this normal curve. So we're going to draw the middle line in. That's the mean, x bar. Okay. Then it says x minus 2 sigma. Okay, that means we're subtracting 2 standard deviations. So x bar minus 1 sigma, x bar minus 2 sigma. Okay, and then it says up until the mean. So what we have is the part we want. We want it between x minus 2 sigma, x bar minus 2 sigma, and x bar. So we're looking for this area. Okay, and if we can find that area, we can find the probability. Well, the area under the curve are those percentages. So remember again, if this is the middle, one standard deviation was 68%. So that's 34% because it's half of the 68, and this is 13.5%. You can use percents or decimals. So if we take 34 and 13.5, we're going to get 47.5, which is going to be a percentage. So 47.5% would lie within 2 standard deviations below and the mean. Okay? So on the next one, the blood cholesterol readings for a group of women are normally distributed. So that's, again, normally distributed. We're not doing binomial. And there's not just 2 outcomes. It's telling us it's normally distributed. So that's when you want to go ahead and make a normal curve. Okay, draw in the middle. You draw the line underneath it. I'm going to draw that in. It says it's normally distributed with a mean of 172. So here's where we're going to put the numbers actually on it. So it's not just doing x bar and sigma. And a standard deviation, so remember that sigma of 14 milligrams per deciliter. So if we look at that, what we want to do is we want to figure out what are our boundary lines. Okay, we know 1 standard deviation above, 2 standard deviations above, and so forth. But what we're doing is we're taking sigma to equal 14 and we're adding and subtracting that from the mean. So if I take 172 and I add 14, I get 186. If I add 14 again, I get 200. If I subtract 14 from 172, I get 158. If I subtract 14 from that, I get 144. Okay, and I can keep going. That's only 2. But if we look at our problem, we look at part A, about what percent of the women have readings between 158 and 186. So I already have enough on here. So here's 158, here's 186. We are looking for this part in between. So if we're looking for that part in between, we have to know what percentages we're talking about. Okay, well that's 1 standard deviation above or below. So we should be able to recognize pretty quickly that that is 68%. Okay, that's just 1 standard deviation above and below. Or we can write our numbers on here. We write our numbers on, this is 34%, this is 34%. Okay, so 34 is 68. So then it says, readings less than 158 are considered desirable. About what percent of the readings are desirable? Well, again, if we go back, here's 158. It says readings less than that are desirable. So less than that would be everything under the curve to the left of 158. So we want to know what readings are desirable. And we only went 2 standard deviations below. Remember, there's another standard deviation above and below. So we could either find those 3, okay, we could do that, or if we start in the middle, we know that basically from the middle to the left, all we're doing is taking 50% and subtracting this 34%, which is between 158 and 172. So if we take 50 and subtract 34, that's going to give us 16%. So 16% would be the part that is less than 158. Now, you can also write your numbers in there. Okay, remember, this is 13.5%. I'm running out of room to put my percent. This is 2.35% here. And the little tail part is 0.15%. So if we were to add up 13.5 plus 2.35 plus 0.15, it will also give us 16. So you can get it either way. Either subtracting the 50% minus the 34 or adding up the 3 parts. But remember, you've got to separate it into 4 pieces on each side. 34, 13.5, 2.35, and 0.15. So then it says, what is the probability that 2 randomly selected women will have desirable readings? Well, from part B, we found that 16% of the readings are desirable. So now we have 2 women. So we basically just have 2 events going on here. So we're going to take 16, which I'm going to change it to a decimal, and multiply it by 16. Whenever we're multiplying, we want to make sure we're using the decimal. So this is the first woman, 16%, second woman, 16%. So 0.0256, or about 2.56% of women, 2 women would have desirable readings here. Okay. If that's a little muddy for you, you're like, what's going on? You might want to go back and just try that same one, maybe without listening to the video, just going back and just trying it again on another sheet of paper. Okay, then the last thing we have to do then is take a binomial distribution and get a normal approximation. So it says when n, remember n is the number of trials, is large, it can be tedious to compute binomial probabilities using the formula that we did yesterday. So think about, you had to do one that had an n of 10. Think if n was 100. You would not want to do that for 100 trials. It would take forever, even with some technology. So it says, if these 2 conditions are met, if both n times p, which is number of trials times the probability of success, is greater than 5, or equal to, and n times the probability of failure, so the number of trials times the probability of failure is also greater than or equal to 5, then you can take the binomial distribution and approximate it with a normal distribution. The mean, this is a formula you're going to have to know, the mean is n times p, number of trials times probability of success, which you would have already tested over here to make sure it works. And then the standard deviation is the square root, so don't forget the square root part, of n times p, which is the number you just found, that's also the mean, where n times p is the mean, x bar, from over here, times the probability of failure. And again, you would take the square root of that. Okay, so let's see how that works. It says, suppose that in a nationwide poll, 72% of households owned at least 1 car. You conduct a random survey of 129 households. What is the probability that at least 98 of them own at least 1 car? If we were going to be doing this, we would be doing the probability that k is greater than or equal to 98. So you would have to do 98, 99, 100, and so forth, all the way up to 129. That would take a very long time to do. So what we can do is we can try to figure out, can we do this using a normal distribution? So we have to check n times p. It has to be greater than or equal to 5. So n is 129. P, probability of success, is 0.72. That is 92.88. Now you would want to try that, n times p times 1 minus p. So that was our formula from over here. N times 1 minus p, not n times p, my bad. Let's erase that. N times 1 minus p. I look back. So n, again, is 129. 1 minus p would be 1 minus 0.72, which is the probability of failure. So we're doing 129 times 0.28. So if we multiply those together, I don't have that written on my paper. So 129 times 0.28, that gives me 36.12. So since this number is greater than or equal to 5, and this number is greater than or equal to 5, so probability of success times number of trials, probability of failure times number of trials. That's just making sure we have enough trials here. Then we can approximate it using a normal distribution. So what we have to do is we have to find the mean, and we have to find the standard deviation. So the mean is actually, if you look back at those formulas, 92.88. That's the mean. The standard deviation is the square root of n times p. And you can write that in, but it's 92.88. That's n times p times 1 minus p. So 1 minus p was that 0.28. So if you take and multiply 92.88 times 0.28 and take the square root, you get about 5.1. So what we're going to do is we're going to make our normal curve. We're going to put our mean in the middle, 92.88. And we need to try to get to 98. So 98 is obviously above the mean. So we're going to start adding 5.1 until we figure out how many times we have to add it. So if I take 92.88 and add to that 5.1, we get 97.98. Well, 97.98 is really, really close to 98. So it's asking, find the probability that at least 98 of them own at least one car. So that would be from here and above. So again, we can either add the three pieces together. Remember, those three pieces would be 13.5%, 2.35%, and 0.15%. Or we know that that half is missing, not 0.1, whoops. We know that that half is missing 34%. So we can take 50% minus 34%, and we would get 16%, or 0.16. Right, so again, we're just using those formulas to approximate a binomial distribution using a normal distribution, just to make our work easier. And you should find that these values down here should end up working out for what they've given you, otherwise you'd use the wrong formulas. Okay, so from there you have homework for tonight, due tomorrow. So 6B.3 day 1 on your assignment sheet. There's also a little half sheet of worksheet that goes along with these problems here for example 4, so make sure you pick that up. Again, quiz tomorrow over section 0 and section 2. If you have any questions, I will be here today after school. I'll also be here tomorrow morning. Hope you have a great day.
Yeah.